Welcome to The Explainer. Today, we're diving headfirst into one of the most fascinating tech collisions happening right now. We're talking about how digital twins and artificial intelligence are literally revolutionizing modern manufacturing. This isn't just some small incremental upgrade. No, what we're looking at here is the literal blueprint for the metafactory of the future. Here's our roadmap for today. First up, we'll look at the cost of downtime. Then, we'll define the digital twin, meet the AI virtual engineer, check out some real-world digital factories, and finally, wrap up with the future of production. Let's get into it.
Section 1. The cost of downtime.
So here's a question for you. How do you redesign an entire factory without stopping production? Honestly, the biggest headache for manufacturers today is risk. You simply can't hit pause on a multi-million-dollar assembly line just to experiment with a new layout or, train a new robot. In the physical world, trial and error literally equals unplanned downtime. And let's be real, unplanned downtime is absolutely the biggest enemy of profitability in any industrial setting. It's a massive deal.
Traditionally, trying to optimize a factory meant relying on some seriously crude physical testing. Imagine teams spending days building these massive cardboard mock-ups of assembly lines just to test out spatial layouts. It's kind of like the world's most expensive elementary school diorama. It's costly, it's incredibly slow, and it disrupts the whole shebang. But today, we have virtual testing. It gives us this completely safe sandbox that never ever stops the actual production line. Teams can ideate, test, and validate everything with absolutely zero physical risk.
All right, moving on to Section 2. Defining the digital twin.
Now, this is absolutely crucial to understand. A digital twin is way more than just some fancy 3D visual. By definition, it is a precise, living virtual replica of a physical asset or system. And the key word there is living. It's fed continuously by real-time IoT sensors and engineering data. It actually breathes the exact same operational data as its physical counterpart, mirroring its performance, temperature, speed, everything in absolute real time.
To actually build one of these, the digital twin acts as a single, unified hub of trusted engineering data. We're talking about pulling together all these totally disparate data feeds. So, taking highly accurate 3D laser scans of older brownfield facilities, real-time transactional data, basic spreadsheets, native CAD files, the works. It wraps all of this information around an asset to create a complete, actionable virtual replica. It's a replica that engineers can instantly query, and more importantly, they can actually trust it.
Section 3. The AI virtual engineer.
Okay, so rather than thinking of artificial intelligence as just some vague algorithm humming away in the background, think of industrial AI as a true, agentic virtual engineer. It's literally acting like an engineer working right inside the digital twin, sitting metaphorically next to the human design team. Its job? To guide and assist by instantly running thousands of complex simulations and optimizations. Stuff that would honestly take humans weeks to calculate, it does in a flash. Just look at this constant circular loop of improvement. The AI is constantly ingesting just massive amounts of real-time data straight from the twin. It processes it, refines its algorithms, and then actually operationalizes those decisions. It learns an awful lot like a human brain does, but on an astronomical scale. It's testing countless scenarios in the digital world, finding the absolute best, most optimized solutions, and then feeding them right back to the physical factory floor. And the best part? It does all of this without ever interrupting actual production. To pull this off, the virtual engineer uses 5 distinct types of enhanced analytics. First up, predictive AI. This forecasts exactly when a machine might fail in the future. Then there's performance AI, which anticipates when the physical floor might actually fall out of sync with expected targets. Now, if something does go wrong, prescriptive AI steps in to identify the root causes and actively prescribes the remedies. Meanwhile, you've got prognostic AI looking at the long-term health and life cycle of the asset, and perceptive AI enhancing overall situational awareness. When you put all 5 together, it gives human engineers a literal superpower. They can anticipate maintenance, drastically lower their costs, and really maximize the lifespan of their physical equipment.
Which brings us to Section 4. Real-world digital factories. Let's see this in action.
Amazon gives us a genuinely incredible case study for this. They actually build full-scale digital twins of their fulfillment centers to train their autonomous warehouse logistics robots. Well, recently, they introduced this highly reflective tape to their physical packing materials, and it completely messed with the robot's physical perception systems. They've started failing. But instead of shutting down a real, massive warehouse to troubleshoot, Amazon just generated photorealistic, synthetic data inside their digital twin to simulate that new tape,
They retrained their AI models virtually and deployed the fix. That literally saved them weeks of physical downtime. Pretty amazing, right?
Foxconn, the world's largest electronics manufacturer, does something similar. They use their digital twin as a virtual robot gym. Basically, before they pour a single ounce of concrete or install a single physical machine, they validate the entire assembly line layout digitally. They're simulating robot trajectories, figuring out camera placements, and testing AI runtime behaviors all before physical deployment. Doing it this way means they completely avoid the enormous punishing costs of physical change orders during the actual construction phase.
And the results of taking this virtual-first approach? They're staggering. By planning out the entire factory in advance using AI and digital twins, manufacturers like Foxconn are reporting a massive 40% reduction in the time it takes to construct and launch a totally new factory. 40%! That is a massive, game-changing acceleration when it comes to time to market.
And it doesn't stop once the doors open. Once these facilities are up and running, deploying these intelligent digital twin solutions and AI predictive maintenance can lead to a 30% or even more reduction in costly, unplanned downtime. Think about it like this. Imagine if your own car or your laptop could tell you exactly when it needed a repair, way before it ever actually broke down. That's the exact kind of resilience we are talking about here, just scaled up to a massive industrial level.
All right, Section 5, the future of production.
So, where is all this taking us? As digital twins really become the ultimate source of truth, and these AI agents take over more complex decision-making, are we actually heading toward fully autonomous dark factories? We're talking about meta-factories that continuously self-improve, self-correct, and optimize their own layouts entirely in the virtual world before seamlessly updating the physical machines on the floor. It really makes you wonder, actually, scratch that, it makes you realize that human engineers might soon step away from manual troubleshooting entirely. Instead, they'll just be supervising the creativity and strategy of these self-improving ecosystems. Honestly, it's a thrilling frontier.
So, the big takeaway here? The physical world is being completely reimagined right now through the lens of digital engineering. The rules are changing. If you want to keep exploring this frontier and understand what happens next as AI completely transforms the physical tools we use every single day, be sure to hit that subscribe button to our channel. You definitely won't want to miss our next explainer. Thanks so much for joining me, and I'll catch you next time.